Welcome to G Fun Facts Online. Every year in mid-August, the heavens offer a spectacular light show, the Perseid meteor shower. These are not just shooting stars. They are a direct connection to the cosmic history of our solar system. Tiny fragments of a giant comet burning up in a final, fiery display. To understand the Perseids is to journey through ancient history, mythology, and the fundamental physics of our universe. So let's get right into the anatomy of this celestial summer spectacle. For at least 2,000 years, humanity has watched the Perseids. The earliest known records come from China in 36 CE, where astronomers noted that more than 100 meteors flew thither in the morning. But in the Western world, the shower is famously known by another name, the Tears of St. Lawrence. The story goes that on August 10, 258 CE, a deacon of the Roman Catholic Church named Lawrence was martyred during the persecution of Christians by the Roman Emperor Valerian. Legend says he was roasted to death on a gridiron, and ever since, the Perseid meteors, which peak around the anniversary of his death, are seen as the saint's fiery tears falling from the sky. The name Perseids itself, however, comes from Greek mythology. The meteors appear to radiate from a point in the sky within the constellation Perseus, named for the Greek hero who slew Medusa. The name Perseids, or Perseide in Greek, means the sons of Perseus, as if his offspring were streaking across the night. While these stories are captivating, the scientific breakthrough didn't happen until the 19th century. In 1866, the Italian astronomer Giovanni Schiaparelli made a revolutionary discovery. After calculating the orbit of the Perseid meteoroid stream, he found it was a near-perfect match for the orbit of a recently discovered comet, now known as Comet 109P/Swift-Tuttle. This was the first time a meteor shower was definitively linked to a specific comet. Schiaparelli proved that meteor showers aren't an atmospheric phenomenon, but the result of Earth passing through the trail of dust and rock left behind by a comet. This brings us to the fiery heart of the matter, Comet 109P/Swift-Tuttle. This is the parent of the Perseids. Each time this comet swings through the inner solar system, the sun's intense heat vaporizes its icy surface, a process that releases a stream of dust and rock into space. When Earth's orbit intersects this debris trail, we get the Perseid meteor shower. Comet Swift-Tuttle itself has a fascinating history. It was independently discovered by American astronomers Lewis Swift and Horace Tuttle in July 1862. With an orbital period of about 133 years, it was predicted to return in the early 1980s, but it didn't show up as expected. This caused some uncertainty until a strong outburst of Perseid meteors in 1991 and 1992 signaled the comet was near. Finally, on September 26, 1992, a Japanese amateur astronomer named Tsuruhiko Kiuchi rediscovered the returning comet. Subsequent research has traced observations of Swift-Tuttle back even further to sightings recorded by Chinese astronomers in 69 BCE and 188 CE. These ancient records were crucial for refining our understanding of its orbit. And it's a good thing we have, because Comet Swift-Tuttle is an absolute giant. Its nucleus is estimated to be about 26 kilometers, or 16 miles in diameter. To put that in perspective, that's significantly larger than the asteroid believed to have caused the extinction of the dinosaurs. Its massive size, and the fact that its orbit crosses Earth's, has led some to call it the single most dangerous object known to humanity. An impact would be catastrophic, releasing somewhere between 27 and 300 times the energy of the Chicxulub impactor. Now, before you panic, here's the good news. Initial calculations after its 1992 rediscovery raised some concerns about a potential impact in the year 2126. However, once astronomers incorporated those ancient Chinese observations into their models, they were able to refine the comet's trajectory with much greater accuracy. They have definitively ruled out any possibility of a collision for at least the next 2,000 years. The comet is predicted to make a close approach on August 5, 2126, but it will pass at a very safe distance of about 14.2 million miles. So while Swift-Tuttle serves as a stark reminder of the dynamic and potentially hazardous nature of our solar system, there is no immediate threat. Now, what actually happens when one of these tiny pieces of comet debris meets our planet? What we call a shooting star is actually a meteoroid, a particle of cosmic dust, usually no larger than a grain of sand, burning up as it enters Earth's atmosphere. And they are moving incredibly fast. Perseid meteoroids slam into our atmosphere at about 59 kilometers per second, or 37 miles per second. At that speed, the collision with air molecules creates immense friction. This compresses and heats the air in front of the particle to thousands of degrees Celsius. The intense heat instantly vaporizes the meteoroid in a process called ablation, creating a brilliant, glowing trail of light. The light we see isn't from the tiny particle itself, but from the much larger region of superheated glowing gas surrounding it. This process also creates a trail of ionized particles, a plasma trail, that can sometimes be detected by radar. The color of a meteor can even tell us about its chemical composition, as the heat excites atoms in the meteoroid and the air, causing them to emit light at specific wavelengths, just like a neon sign. The debris trail left by Comet Swift-Tuttle isn't a uniform cloud. It's a vast, elongated stream with its own complex structure. The density of particles varies. The core of the stream has a higher concentration, and when Earth passes through this region, we experience the peak of the shower. But there are also filaments of more recently ejected material. For instance, a dust filament shed by the comet in 1865 can sometimes cause a smaller secondary peak a day or so before the main one. This is also why the intensity of the Perseids varies from year to year. In the early 1990s, when the comet was close to the Sun, observers reported rates of several hundred meteors per hour. In a typical year, you can expect to see between 50 and 100 meteors per hour at the peak, assuming you have dark skies. The Perseids are also famous for producing a high number of very bright meteors, known as fireballs. These are caused by larger particles of cometary debris, perhaps the size of a pebble or a marble. They can be as bright as the planet Venus and leave spectacular, long-lasting trails. An even rarer phenomenon is an earthgrazer. This happens when a meteoroid enters the atmosphere at a very shallow angle, essentially skimming along the upper layers before exiting back into space. Earthgrazers are incredible to see, characterized by long, slow, colorful paths that travel horizontally across a huge portion of the sky. The best time to spot them is in the early evening, just as the shower's radiant point is rising near the horizon. So how can you see this for yourself? The best part about the Perseids is that you don't need any special equipment. The shower is active from mid-July to late August, but the peak, when you'll see the most meteors, typically occurs around August 12th or 13th. The best time to watch is from midnight until the hours just before dawn. This is because after midnight, your side of the Earth is facing into the direction of its orbit, essentially sweeping up more debris, like the windshield of a car driving through a swarm of insects. The meteors will appear to come from a point in the constellation Perseus, known as the radiant. But you don't need to stare directly at it. In fact, it's better not to. Meteors that appear further from the radiant will have longer, more dramatic trails across the sky. Most important thing for a successful viewing is to get away from city lights. Light pollution will wash out all but the brightest meteors. Find a dark spot in the countryside or a park. Comfort is key. Bring a reclining chair or a blanket so you can lie back and look up without straining your neck. And be patient. It takes about 20 to 30 minutes for your eyes to fully adapt to the darkness. Avoid looking at your phone, as the bright screen will instantly ruin your night vision. If you need a light, use a red flashlight, which has less of an impact. One final factor is the moon. A bright full moon can act like a giant source of light pollution, making it difficult to see the fainter meteors. In years when the peak coincides with a new moon, conditions are perfect. When a bright moon is out, the number of visible meteors will be reduced, but the bright fireballs will still cut through the glare, so it's always worth a look. And for those interested in photography, capturing the Perseids is a rewarding challenge. You'll need a camera with manual controls, a wide-angle lens, and a sturdy tripod. Set your lens to its widest aperture, manually focus it to infinity, set your ISO between 800 and 3200, and use a shutter speed of about 15 to 30 seconds. Then, take continuous shots. The more time your shutter is open, the greater your chance of catching a meteor streaking through the frame. The Perseid meteor shower is more than just an astronomical event. It's a shared human experience that connects us to the cosmos, to our history, and to each other. From ancient myths to the modern understanding of comets, the Perseids remind us of our place in a vast and dynamic universe. So this August, find a dark spot, lie back, and watch the dust of a mighty comet grace our summer skies. Thanks for listening to G Fun Facts Online.